In this video, we are going to do question number 3, 4, 5 of exercise 2.3. So the question number 3 says, obtain all other zeros of 3x raised to power 4 plus 6x cube minus 2x square minus 10x minus 5. So it is a biquadratic polynomial. Biquadratic means where the degree is 4, right? So since the degree is 4, then it must be having 4 zeros, out of which 2 zeros are given as root 5 by 3 and minus root 5 by 3. So remaining 2 zeros we need to find. So how to do this? First of all, what we'll do is we'll put the first 0 equal to x. Why so? Because zeros are values of x, isn't it? Zeros are values of x. So first of all, I'll put x is equal to root 5 by 3, and on taking this root 5 by 3 towards LHS, I'll get x minus root 5 by 3, isn't it? So that x minus root 5 by 3 will be one of the factor. So this first factor is x minus root 5 by 3. Next, now put x is equal to minus root 5 by 3, because it is also a 0. So if I take this minus root 5 by 3 towards LHS, I'll get x plus root 5 by 3, and that will be the other factor. Okay, and on multiplying these two factors, I'll get a new polynomial, and that will be a factor as well. So a minus b into a plus b is a square minus b square. So you can see a means x here. So a square means x square minus b square means the square of root 5 by 3. I'll just write square of root 5 by 3, and square of root 5 by 3 is 5 by 3 itself. So this is also a factor of this biquadratic polynomial. Now what we'll do, we'll divide this polynomial, this biquadratic polynomial with this quadratic polynomial. Okay. So dividing this 3x4 plus 6x cube minus 2x square minus 10x minus 5 by x square minus 5 by 3. So with what term should we multiply x square with so that we get 3x4? Okay. So first of all, since we require x raised to power 4, we need x square, isn't it? So on multiplying x square with x square, we'll definitely get x4. Also we'll be requiring 3. Only then we'll get 3. So 3x square into x square is 3 into x raised to power 4. Right? So here you can see I have written 3x raised to power 4, and the quotient I have taken is 3x square. Also when we multiply minus 5 by 3 with this 3x square, what will happen? This 3 will cancel this 3, and minus 5 into x square is minus 5x square. Up to this point, I think everything is clear. And now one more thing you observe here, that square term is written under a square term and biquadratic term is written under a biquadratic term. And now we'll change sign. Positive will become negative, negative will become positive, and now this term will be cancelled, and plus 5x square minus 2x square will be 3x square. So this 3x square you can see, and this 6x cube will come as it is, minus 10x as it is, and minus 5 as it is. Now what should be multiplied to x square to get 6x cube? So what should be multiplied with x square to get 6x cube? First of all, we need x cube. It means I need to multiply this with x. Only then I'll get x cube. X square into x is x cube. Also I require this number 6. So 6 should also be there. So x square must be multiplied with 6x. Therefore you can see 6x is here in the quotient. So x square into 6x is 6x cube. And when minus 5 by 3 will be multiplied by 6x, this 3 will cancel this 6, and I'll be left with minus 5 into 2x. I'm repeating myself. If we multiply minus 5 by 3 with 6x, 3 will cancel 6x, 3 will cancel 6x, and here we'll get 2, and minus 5 into 2x will be minus 10x. Right, this one. Again you can see x term is written under x term and x cube term is written under x cube term. And then changing the sign, this will cancel out. This will be cancelled out and this will be cancelled out, and now we have 3x square minus 5, right? So finally, what should be multiplied in x square to get 3x square? The answer is 3 only. So I have written 3 here, so x square into 3 is 3x square, and minus 5 by 3 into 3 will be minus 5, because 3 will cancel 3, so minus 5 will be remaining. And now just change the sign of this 3x square and minus 5, and now we can cancel them. 3x square minus 3x square is 0, and minus 5 plus 5 is 0. And this had to happen because on dividing a polynomial by its factor, always remainder is 0. Now next step is we will solve this polynomial to get its 0. So since it is a quadratic polynomial, there should be 2 zeros. Let us see. Okay. So what I have written, this biquadratic polynomial is equal to x square minus 5 by 3. X square minus 5 by 3 was its factor, right? Into this polynomial. And also you must have known to this division algorithm, right? What does division algorithm tells you? That this dividend is equal to quotient into divisor plus remainder. So this dividend should be equal to x square minus 5 by 3 into this 3x square plus 6x plus 3, and remainder is 0. Therefore we need not write the remainder, otherwise we would have written plus whatever the remainder term is here. So this you got. Now we'll just find the zeros of this polynomial. First of all, I have taken 3 common outside, and now it is x square plus 2x plus 1. What is x square plus 2x plus 1? X square plus 2x plus 1 is square of x plus 1. You try to solve this x plus 1 square, what you will get? A square, that is x square, right? 2 into a into b means 2 into x into 1, that is 2x, plus b square, that is 1. So this x square plus 2x plus 1 is x plus 1 whole square. So we can write it as x plus 1 whole square, and on putting it equal to 0, we'll get x is equal to minus 1. Okay, so we were talking about 2 more zeros, but then student asks, sir, we got only 1. Actually both the zeros are minus 1 only. Okay, because x plus 1 square means x plus 1. X plus 1 square means x plus 1 multiplied by x plus 1, isn't it? So by the first factor you got minus 1, and from the second factor also you got minus 1. So this will give minus 1, this will also give minus 1. So it means both the zeros are minus 1 only. Okay, now question number 4. Question number 4 says, on dividing this term, this polynomial, let me write it here. On dividing this polynomial, let us say this is px. Okay, so on dividing this polynomial x cube minus 3x square plus x plus 2, and we are dividing it with gx, and gx is not given. Okay, no problem. Gx is not given, that is divisor is not given, but quotient is given as x minus 2, so that is good. Quotient is x minus 2, and also remainder is given as minus 2x plus 4. Let us call it rx. Okay, so these are the standard notation of dividend, divisor, quotient and remainder. So by the division algorithm, this dividend is equal to divisor into quotient plus remainder. Okay, this we have studied in Euclid division lemma also, right? So dividend is divisor into quotient plus remainder. So I have written this here. Now dividend is this term which is being divided. Divisor means the term which is dividing. Okay, so gx, this term is divisor, into quotient, that is qx, you can write, plus remainder, that is rx. Okay, so we have put the value divisor at it as it is, since we don't know the value. Quotient is x minus 2 plus remainder is minus 2x plus 4. Now I need to find the value of this gx. Okay, what I'll do, first of all, this term I'll take towards LHS. So negative 2x will become positive 2x, and plus 4 will become minus 4 after going to the LHS. and at the RHS we are left with gx multiplied by x minus 2. So you can see gx multiplied by x minus 2. This is multiply symbol, right? And now here x cube as it is, minus 3x square as it is, x plus 2x is 3x that you can see here, and 2 minus 4 is minus 2. Okay, so 2 minus 4 is minus 2. Now what is the value of gx? We'll take this x minus 2 towards LHS, and since it is being multiplied here, there it will go in division. That is, it will become the denominator at the LHS. So now gx is equal to x cube minus 3x square plus 3x minus 2 divided by x minus 2. So now again we have to do division. We have to divide this polynomial by this polynomial. Okay, so let us see. Now we are dividing x cube minus 3x square plus 3x minus 2 by x minus 2. So what should be multiplied in x so that we get x cube? So it has power 1 and we require 2 more powers to make it 3. So we'll multiply it with x square. So x into x square will give you x cube. So x into x square is x cube and minus 2 into x square is minus 2x square. And now we'll change the sign. So positive will become negative and negative will become positive. Cancelling these terms. Minus 3 plus 2. Minus 3 plus 2 is minus 1. So minus 3x square plus 2x square will be minus 1x square. So this is how we got this. And then 3x as it is and minus 2 as it is. Now what should be multiplied in x so that I get minus x square? So you want to find what should be multiplied in x to get minus x square. First of all, you need a negative term. And here we have one power, one more power will be requiring to get x raised to power 2. So x into minus x will give you minus x square. Therefore, you can see the quotient here is minus x. So x multiplied by this minus x is minus x square, and minus 2 multiplied by minus x is plus 2x. Negative into negative is positive. So minus 2 into minus x will give you plus 2x. Now we'll change the sign. Negative to positive and positive to negative. Now again this will be cancelled, and 3x minus 2x will give you x, and this minus 2 will come as it is. Now what should be multiplied in x minus 2 to get x minus 2? 1 only. X into 1 will be x, minus 2 into 1 will be minus 2. Therefore quotient, the next term is plus 1. And now we'll change the sign, and x will cancel minus x and minus 2 will cancel plus 2. So we'll get remainder 0, and hence we got our answer gx, right? And now last question we'll see. So here the question is, give example of polynomial px, gx, qx, rx which satisfy the division algorithm, and first degree of px and degree of qx must be same, right? So let us come to a simple question. So first of all, understand, again I am repeating, so I'll go to that page only, right? Why to write again? Here what I taught you. Px means which is being divided, that is dividend. Qx means, gx means the divisor, qx means quotient, rx means the remainder. So the question is that p and q must have same degree. This is the question. So when you want p and q to be of same degree, you need to take gx is equal to a constant. A constant, that is a term without any variable with it, right? So what they said, that px and qx must be same. So for px and qx to be same, that is the dividend and quotient to be same, the divisor should be a constant. So this is a simple point. So what we have done, I have taken just a polynomial, a quadratic polynomial px, right? And gx I have taken a constant which can divide this easily, isn't it? 2 3s are 6, 2 1s are 2, 2 1s are 2. Easily gx can divide px, and so we can get quotient 3x square plus x plus 1 and remainder 0. I'll do this question for you. Let us say 6x square plus 2x plus 2, and I want to divide it with a constant, because on dividing with a constant we'll always get the degree of dividend and quotient same. So see, what should be multiplied to 2 to get 6x square? The answer is we have to multiply it with 3x square, because 2 3s are 6. So, and x square is there, so 2 3s are 6, x square you will get, right? So this will be cancelled. Next, what should be multiplied to 2 to get 2x? To get 2x, this need to be multiplied by x. So 2 into x will give you 2x. So this will also be cancelled later on. And what should be multiplied to 2 to get 2? 1. 2 1s are 2. Therefore the quotient we got is 3x square plus x plus 1. Got it? So now you see the degree of q is 2 and degree of p is also 2, because we followed this simple rule that we need to take divisor as a constant. Okay. Now just examples we need to give. That example we have given. Next is the degree of quotient and remainder should be same. Degree of quotient and remainder should be same. So what we have done this time, we have taken the polynomial x cube plus x. X cube plus x. You can take any polynomial of any degree. You could have taken a quadratic polynomial or biquadratic polynomial, right? And now dividing this x cube plus x with a polynomial with 1 degree less. 1 degree less. So if you are taking biquadratic here, take cubic here. If you are taking cubic here, take square here. If you take square here, take linear here. If you take linear, take constant here. Like this. 1 degree should be less for the divisor. And now you divide it. So x square into x will give you x cube, right? And on changing the sign, these terms will be cancelled and we'll have x. Now what can be multiplied to x square to get x? Nothing. Why? Because this is the degree of this x is 1 and degree of x is 2. So if you multiply it with anything, like if you multiply it with 1, you will get x square. If you multiply it with x, you will get x cube. You can't ever get lesser term, lesser degree term, right? So now we can't further divide it. So see, this quotient and remainder are of same degree, isn't it? So this is the process by which you can do this question. Okay. Now next, third one, where degree of remainder is 0. Degree 0 means remainder is a constant term. So for this you can take the same example as in example 1, because there also remainder was 0, and 0 means the degree of remainder is 0, isn't it? This is a constant, so the degree is 0. So you got examples for all the 3 parts. Now this video is over. Thank you for watching.